Hi there, Mr. Sutton here with the Pre-Cal Honors 510 Part 2 homework solutions on Pythagorean identities. On this problem, there's a few ways you could have gotten started. One would have been to FOIL this out, or actually distribute this out. Another would be to try to deal with this squared trig function. I went for the squared trig function, so I know that sine squared plus cosine squared equals 1. And I can get the pattern 1 minus cosine squared if I just subtract cosine squared from both sides. That means that 1 minus cosine squared is equivalent to sine squared. So I'm going to go ahead and replace this parentheses with just sine squared of x. Now this is a good move because we know that cosecant is really 1 over sine of x, so there's going to be some interaction between these terms. So that means that I can cancel out the sine of x down here with one of these signs, which means that all I've got left is just sine of x. On this problem, we've got a whole bunch of squared trig functions, so we should probably be thinking Pythagorean identities at some point. Not sure if now is the right time, though, because cotan squared and cosine squared are not in the same identity, so I'm not really sure how those are going to interact. One other thing we could do at this point, algebraically, is factor out a cotan squared of theta. If we do that, that will leave us with 1 minus cosine squared of theta. And now 1 minus cosine squared, that looks like something out of a Pythagorean identity. I've got sine squared plus cosine squared equals 1. So that means 1 minus cosine squared is the same as sine squared. I'm going to go ahead and replace this 1 minus cosine squared with sine squared because that's simpler looking. All right, now I know there's got to be something I can do with cotan squared and sine squared. Cotan squared I know is really cosine squared over sine squared. That means that I can cancel out this sine squared down here and the sine squared up here, which leaves us conveniently with just cosine squared. For this problem, I have tan of x over secant of x that I'm trying to simplify. Now there really isn't a whole lot else to do on this one in terms of squared trig functions or algebra, so that leaves us with the last thing in our toolkit, just kind of turning everything into sine and cosine. Tangent, for example, I can rewrite as sine of x over cosine of x. And then on the bottom of this big fraction, secant, we know that's really 1 over cosine. So now I can use a little bit of algebra to simplify this. To multiply by 1 over cosine of x, I'm going to multiply by the reciprocal, same change flip. So I've got sine of x over cosine of x times cosine of x over 1, or just simply cosine of x. In this situation, since I'm multiplying and I have a cosine on the top and the bottom, I can cancel those cosines, and that leaves me with just sine of x. This problem is a little bit tricky to get started on trying to simplify this. We see these squared trig functions, so immediately we're thinking we can go to Pythagorean identities and do something, but there isn't really a whole lot that we can do that's useful at this point. For example, if you swap out sine squared with 1 minus cosine squared, where are you going to go from there? Another thing we could do algebraically is get a common denominator and merge this into one fraction. But again, once you do that, there won't really be anywhere to go. You're going to have tan squared minus sine squared upstairs, and that doesn't really come out to anything nice. One other thing we could do is try to get rid of these fractions altogether. So for example, we could write this as cosecant squared of a, and 1 over tan squared of a is equivalent to cotan squared of a. Now the reason this is nice is because there is a Pythagorean identity that has both of these trig functions in it. That would be 1 plus cotan squared equals cosecant squared. So I can do a little bit of rearranging here to get this cosecant squared minus cotan squared pattern. To do that, I would have to subtract cotan squared from both sides in this identity. And that would leave me with just 1 on the other side. So wherever I see cosecant squared minus cotan squared, I can just replace that with 1. Well, here it is. I'm just going to replace that with 1. On this problem, it's not necessarily clear what we need to do at the very beginning. We have a squared trig function, but trying to replace that with some Pythagorean stuff, I don't know if that's going to help us immediately. Maybe it will, who knows. One thing we can do in the beginning algebraically right away, we notice that we have cosine squared and a cosine over here, so there is a common factor of cosine that you could take out right away. And if you take out that factor, that'll leave us with cosine squared plus sine squared inside. Now the reason that's nice is because we have the identity sine squared plus cosine squared equals 1. So I can actually replace everything in this parentheses with just 1. And now cosine of y times 1 is just cosine of y. On this problem that I'm trying to simplify, it's a little bit of a mess. We have stuff being subtracted in the denominator, stuff being multiplied in the numerator. Not really much we can do algebraically on this one. But we do have this squared trig function. So what identity has cosine squared in it? Well, sine squared plus cosine squared equals 1. And if I rearrange this by subtracting cosine squared from both sides, I get the pattern 1 minus cosine squared equals sine squared. So wherever I see 1 minus cosine squared, I can replace it with sine squared. That would be a nice thing to do down here in this denominator. If I replace 1 minus cosine squared with sine squared, well, now I have something that can cancel out this sine upstairs. So this sine and one of the two sines down here is going to cancel. That just leaves me with cosine of x over sine of x. And I can simplify that to simply cotan of x. To simplify this one, we're going to have to do a little bit of multitasking. So, for example, we need to take care of this fraction. I notice I have a cotan squared up here, and in terms of Pythagorean identities, I know that 1 plus cotan squared equals cosecant squared. Now, that isn't immediately helpful, but one thing we could do if we wanted to, we could replace cotan squared with, if we subtract the 1, cosecant squared minus 1. So I'm going to go up here and actually do that substitution. I'm going to replace this with cosecant squared minus 1. You might not see immediately why that's helpful, but it will be on the next step, and you'll see why. Now, over here, this is a little more obvious. Cosecant is 1 over sine, so that's going to be very helpful pretty quickly. All right, next step now. One thing we see that we can immediately do is cancel out the sine and the sine here. So this is just going to be a big plus 1 in a minute. Now, in terms of this cosecant squared minus 1, the reason this is so helpful is because this is in the format a squared minus b squared. So you can actually factor this into cosecant plus 1 and cosecant minus 1. And we still have that plus 1 over here we just said. Don't forget about that. But going back to this now, we have a cosecant of theta plus 1 that we can cancel out. So when the dust settles, we just have cosecant theta minus 1 plus the 1 that's still over there. And then minus 1 plus 1 cancels, so this just reduces to cosecant of theta.